Typically, indexes are data structures that can store collections' data set in a form that is easy to traverse. Queries are efficiently executed with the help of indexes in MongoDB. Indexes help MongoDB find documents that match the query criteria without performing a collection scan. If a query has an appropriate index, MongoDB uses the index and limits the number of documents it examines. Indexes store field values in the order of the value. The order in which the index entries are made support operations, such as equality matches and range-based queries. MongoDB sorts and returns the results by using the sequential order of the indexes. The indexes of MongoDB are similar to the indexes in any other databases. MongoDB defines the indexes at the collection level for use in any field or subfield. In the next screen, we will discuss index types. MongoDB supports the following index types for querying. Default _ID. Each MongoDB collection contains an index on the default _ID field. If no value is specified for _ID, the language driver or the MongoD creates an _ID field and provides an object ID value. Single field. For a single field index and sort operation, the sort order of the index keys do not matter. MongoDB can traverse the indexes either in the ascending or descending order. Compound index. For multiple fields, MongoDB supports user-defined indexes, such as compound indexes. The sequential order of fields in a compound index is significant in MongoDB. Multi-key index. To index array data, MongoDB uses multi-key indexes. When indexing a field with an array value, MongoDB makes separate index entries for each array element. Geospatial index. To query geospatial data, MongoDB uses two types of indexes, 2D indexes and 2D sphere indexes. Test indexes. These indexes in MongoDB searches data string in a collection. Hashed indexes. MongoDB supports hash-based sharding and provides hashed indexes. These indexes the hashes of the field value. We will discuss the index types in detail later in the lesson. In the next screen, we will discuss the index properties. MongoDB supports indexes on any document field in a collection. By default, the _ID field in all collections have indexes. Moreover, applications and users add indexes for triggering queries and performing operations. MongoDB supports both single field or multiple field indexes based on the operations the index type performs. The command given on the screen is used to create an index on the item field for the items collection. In the next screen, we will discuss how to create single field indexes on embedded documents. You can index top-level fields within a document. Similarly, you can create indexes within embedded document fields. The structure shown on the screen refers to a document stored in a collection. In the document, the Details field depicts an embedded document that has two embedded fields, ISDN and Publisher. To create an index on the ISDN field and the embedded document called Details, perform the queries shown on the screen. In the next screen, we will discuss compound indexes. MongoDB supports compound indexes to query multiple fields. A compound index contains multiple single-field indexes separated by a comma. The command shown on the screen is an example of a compound index on two fields. This diagram depicts a compound index for the fields user ID and score. The documents are first organized by user ID, and within each user ID, scores are organized in the descending order. The sort order of fields in a compound index is crucial. The documents are first sorted by the item field value and then, within each item field value, they are further sorted by the stock field values. For a compound index, MongoDB limits the fields to a maximum of 31. In the next screen, we will discuss index prefixes. Index prefixes are created by taking different combination of fields and typically start from the first field. For example, consider the compound index given on the screen. It has item in the ascending order and available in the ascending order as the index prefixes. MongoDB uses a compound index even if the find queries are for index prefixes fields. It uses indexes for querying the item field, the available field, and the sold quantity field. MongoDB cannot efficiently support the query on the item and sold quantity fields by using index prefixes, as it would be like using separate indexes for these fields. The item field is a part of the compound index and the index prefixes. Hence, the item field should be used in the find query of the index. We will discuss sort order in the next screen. In MongoDB, you can use the sort operations to manage the sort order. You can retrieve documents based on the sort order in an index. If you are unable to obtain the documents sorted from an index, the results will get sorted in the memory. Sort operations executed using an index show better performance than those executed without using an index. In addition, sort operations performed without an index gets terminated after exhausting 32 megabytes of memory. Typically, indexes store field references in the ascending or descending sort order. For single field indexes, MongoDB can traverse the index in either direction. Hence, the sort order is not important. However, for compound indexes, the sort order is important because it helps determine if the index can support a sort operation. In the next screen, we will discuss how to ensure that indexes fit in the random access memory, or RAM. When indexing a field containing an array value, MongoDB creates separate index entries for each array component. These multi-key indexes in queries match array elements with documents containing arrays and select them. You can construct multi-key indexes for arrays holding scalar values, such as strings, numbers, and nested documents. To create a multi-key index, you can use the db.collection.createIndex method given on the screen. If the indexed field contains an array, MongoDB automatically decides to either create a multi-key index or not create one. You need not specify the multi-key type explicitly. In the next screen, we will discuss compound multi-key indexes. In compound multi-key indexes, each indexed document can have maximum one indexed field with an array value. If more than one field has an array value, you cannot create a compound multi-key index. An example of a document structure is shown on the screen. In this collection, both the product_ID and retail_ID fields are arrays. Therefore, you cannot create a compound multi-key index. Note that a shard key index and a hashed index cannot be a multi-key index. In the next screen, we will discuss hashed indexes in detail. The hashing function combines all embedded documents and computes hashes for all field values. However, it does not support multi-key indexes. Hashed indexes support sharding. These indexes use a hashed shard key to shard a collection. This ensures an even distribution of data. MongoDB uses hashed indexes to support equality queries. However, range queries are not supported. You cannot create unique or compound index by taking a field whose type is hashed. However, you can create a hashed and non-hashed index for the same field. MongoDB uses the scalar index for range queries. You can create a hashed index using the operation given on the screen. This will create a hashed index for the item's collection on the item field. In the next screen, we will discuss TTL indexes in detail. TTL indexes automatically delete machine-generated data. You can create a TTL index by combining the db.collection.createIndex method with the expire after seconds option on a field whose value is either a date or an array that contains date values. For example, to create a TTL index on the last modified date field of the event log collection, use the operation shown on the screen in the Mongo shell. The TTL background thread runs on both primary and secondary nodes. However, it deletes documents only from the primary node. TTL indexes have the following limitations. They are not supported by compound indexes, which ignores expire after seconds. The _ID field does not support TTL indexes. TTL indexes cannot be created on a capped collection because MongoDB cannot delete documents from a capped collection. It does not allow the createIndex method to change the value of expire after seconds of an existing index. You cannot create a TTL index for a field if a non-TTL index already exists for the same field. If you want to change a non-TTL single field index to a TTL index, first drop the index and recreate the index with the expire after seconds option. In the next screen, we will be discussing creating unique indexes. To create a unique index, use the db.collection.createIndex method and set the unique option to true. For example, to create a unique index on the item field of the items collection, execute the operation shown on the screen in the Mongo shell. By default, unique is false on MongoDB indexes. If you use the unique constraint on the compound index, then MongoDB will enforce uniqueness on the combination of all those fields which were part of the compound key. Unique index and missing field. If the indexed field in a unique index has no value, the index stores a null value for the document. Because of this unique constraint, MongoDB permits only one document without the indexed field. In case there are more than one document with a valueless or missing indexed field, the index build process will fail and will display a duplicate key error. To filter these null values and avoid error, combine the unique constraint with the sparse index. In the next screen, we will discuss sparse indexes.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.